Okay, so this is chapter 5, and then chapter 5 is like the first section is about the atomic models and all that stuff. So if you want to look at all the atomic models, you should go to page 128 and 129 because it was like so long, so I didn't want to copy it down. And so like the definition of an atomic orbital is a region in space in which there is a high probability of finding an electron. So we remember that an s orbital is like a circle, and the p
Like
orbital is like the 8.
Circle 8.
Circle what?
Circle 8.
It's not
Figure 8? Is it figure 8? Yeah, something like that. Keep going.
So this is like my definition of like how like to remember the differences between the stuff. Like an energy level is just like imagine like the big circle around like the nucleus, and then the sub level is like the p and the s. And then the orbital is actually which way like the stuff stands. So it could be like this way, and that way. So that's how I remember like the differences. And then we learned about electron configuration. And during this time, we had like the 3 rule, like the off law principle, which state that like electrons is like in the lowest energy level first. So that's the S level. So it starts there. And then the Pauli exclusion principle, which is that one orbital can hold at most like 2 electrons, and they have to spin in opposite direction. And then the Hund's rule, which is that like although they can hold 2, but then the electron like to be themselves. So if possible, you should like let them be in their own orbital. And there are exception to like this rule. So you guys should follow like the periodic table, like the SPDF stuff, and or the triangle that we learned in class. And we also learn about light and all that stuff. We also learn about lights and stuff, but I don't think we went into detail into that like in class. So maybe we shouldn't check over it, like about the aptitude and all that stuff. It's like pretty boring. Should I check over it, Diana? Yeah, I don't think I should go over it. Oh, but also, you should remember the Heisenberg uncertainty principle, which state that it's impossible to know the exactly both the velocity and position of the particle in the at the same time. So you can't tell like where it is and how fast it's going at the same time. So that's it.